have marked you.
Thank you for one, on the solid, you're writing, you're taking your business, and two, and four, five. You're not sitting right there. Why we go to the second?
Ready.
Eyes up. Everybody facing forward. Alright, so today we're going to talk about understanding area and quadrilaterals, alright? You guys know, talked about area before in third grade? Fourth grade, alright? It shouldn't be something new to you, so it's more of a review, alright? And we'll talk about quadrilaterals, what those things are, okay? But first, let's talk about something else real quick. So, this weekend I was browsing Amazon, looking for posters for my room, and I came across these two posters that I really like, okay? But they have different sizes. How do I know which one will fit on my wall? Talk about attributes. How do I know which one will fit on my wall? How do I know?
So you call it the width? You use to measure the size.
Seems like a measure the poster. Alright. How do you do?
I think the poster
How do you know the Pokemon?
let's say like I want to do something small, it's something like that right here. Alright, it's kind of
So what I said was that like
What kind of a tiny wall? How do I know it's gonna fit?
order the stuff, I feel like the tell like the wise of like
How can I tell it's gonna fit just by
like
like?
the stuff
basically how you could see if it's the right size. And you can like, you know when you orientation and just like a description under it, you can look at the description and see the length of the side and then on your
What are those things called? What's the nose? Oh, that's what it is. Depending on how big this is. I see if it's on the wall. What my wall is this big? This I'll bring it back in 5, 4. Go last discussions in 3, 2. Yeah, well, there's some good stuff going on. So, who would like to offer the class what they're talking about? Jeremy, go ahead.
All you said that you have to measure the poster by the
find the length and the width, okay. Yes, then,
So yes.
could you elaborate, please?
Oh, and we said, first you gotta find the length and the width of the poster and then see where you can fit the poster on your board, on your wall, to see where it fits at the most or better.
So what about the length and width make this important? Why is that even important? What about the, yes, Elizabeth?
I feel like you need to measure the poster and the wall because, and then after you got that, I feel like you need to divide them to see how much space the poster would take on the wall. Because if you bought like a 150 by 150, then it's gonna take a lot more space on your wall, and you really don't need that much space. So I feel like you're gonna have to add both the wall and the poster. So you're gonna add the length, the area, and the
Okay, so you're saying that depending on the dimensions, they can take up space, right?
yeah.
Okay, good. Anybody else? Yes, to me.
Oh, me and my group said, like before you order, you can look like in the description, like it tells you like the length and stuff, and like how much, like how long it is.
Good, right? So it's like if you looking, it should tell you the dimensions, right? It should tell you the length, right? Well, the length and the width, right? Okay, somebody from group 4 hasn't spoken yet. Group 4.
We said what is it called, the width and the length.
What about the height and width? What about the length and the width? Why are those important?
It has to be like every stuff, and I can't even think of what I'm trying to say.
Who can help her out? Fine.
Like the length and width is important because like you need to make sure that the poster is the right size for your wall. And if you say they can like oversize the wall and maybe like fall down sometimes.
Yeah, so the dimensions are important because it tells you the size of the poster, right? So it tells me how much space, right, this takes up, okay? Alright, so this thing we're talking about space is called area, right? So, you know, once we write this definition down, the area, right? Area is the amount of space taken up by a two-dimensional shape, okay? Alright, when I say two dimensions, I mean what? Length? What else? Say it loud.
What?
Length and width, good. Length and width, alright? It's the amount of space taken up by a two-dimensional shape. Length and the width. That's a two-dimensional shape, so like, technically, we can take the area of this floor we're sitting on, right? We can put it in what we call units, right? Square units, and we can count the number of squares. Actually, there's little squares on the floor right now, right?
Yeah.
See the squares? Everybody look down. You see the squares? You can count these squares, right? From that corner to that corner, and we can find out the area of this floor, right? It will take us a long time, but technically we could do it. Write it down, write it down. So let's take this Pikachu poster for example, right? We can put it in square units, right? We can find the area. So we can do it by counting. So let's count the number of squares we see here. Starting from the top going down. How many we got here? 1, 2. You guys got it with me? 1,
2, 3, 4, 5, 6, 7, 8.
Alright, so we got 8 units up here. Right?
8.4.
Alright, oh, we're getting there. So then we got 8 right here. 1, 2, oh, I mean, we got here. Go this way. 4 units this way. So yeah, we could multiply, or if you don't, if you can't multiply, you can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, all the way down until you get to what? 32. Okay. The second, my multiply. So we have this square, for example, right? We set it up, we counted it up into unit squares, right? Divided up into squares. And we counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the area is 15 unit squares, all right? And the way you can write that is 15 units squared, little t right here, okay? That's it too, so units squared. Make sure you write it down. That's really important. So if you in a standardized test, if you don't write down your units, it'll be wrong. You'll put down 15 in the answer, that'll be incorrect. So if you're working in meters, all right, it's gonna be meters squared. If we're working in inches, it's gonna be what? Inches what? Inches squared. Working in feet, it's gonna be feet what? Feet squared. Because we're doing 2 dimensions, right? What are our dimensions we're working with here? No. So our dimensions are gonna be the length, and width. Okay. Everybody know right?
No.
Give it 10 seconds. All right, so we talked about adding. This is our second way of doing it. Multiply, okay? So Jeremy, I saw you sort of jumped the gun, right? When he counted our length and the width of our units. You automatically said 8 times 4, right? Why you say that?
I said 8 times 4 because there was 4 rows and there was 8 steps.
Good, right?
So I
So,
did 8 times 4, which is 32.
So you basically multiply.
Yeah.
good. So the equation for area is going to be all right. It's going to be the length times the width. All right. And the way to find the length is to find the rows, right? Rows. Yeah, I like to call them columns. What's a row? A row. What's a row?
What do you mean by round?
A row, like ducks in a row.
Oh.
Right. Show how it goes. Like this, right?
Something that goes horizontally.
Something's horizontal, right? So ducks walk in a row, right?
One verse that goes horizontally.
I can't draw a duck. But like they walk in a row, right? I can't draw a duck. But ducks walk in a row, right? They walk. The mother walks, and the babies walk right behind her, right?
Yeah.
In a row. A column is like ancient Roman pillars, right? Celia showed it. It's like this, right? Up and down, right? Everybody show up and down like this for row for columns, right? Yeah. Everybody got this written down?
No.
Oh, not right, you're right. And if you're confused, we'll do an example, sort of clarify this up. Just a second. Moving on in another 15 seconds. Just a-
So you said that a row was something that a set of numbers that goes side to side, right?
Yeah, horizontal.
Yeah, and columns are like ancient pillars, but isn't there like something that goes slanted like up to left?
Yes, there is, but it's not what we're talking about right now. You'll learn about that later on in 7th grade. All right, moving along. So we got our area formula, right? So let's practice it, okay? So someone tell me the equation for area again.
Length times width.
Thank you, Zion. Can somebody else tell me?
Length plus
There we go. L times W. So I'm gonna draw a rectangle. Somebody give me a dimension for our length.
56.
Something smaller, please.
Okay, 10.
10. And what about our width?
Not
5.
8.
5. Okay. So we have our dimensions for our rectangle. We have 10 and 5. All I'm gonna do is plug them in, right?
Yeah.
So area equals what's our length? 10. What's our width?
5.
5. 10 times 5. 50. And let's say we're working in inches. It's gonna be 50 inches what? Squared.
Square.
Alright, what's a little 2 right here?
You have to say 50 inches squared.
Every time.
Oh.
Basically, you did 5 times 10 equals 50.
Yes, I did.
Hold up, be so can I just get this straight out?
Okay, go ahead.
You have to put square after each inches.
Yes. To do that, you just write a little 2 above the inches. Okay? Everybody got this written down? Good. Take another 30 seconds.
We gotta draw it.
Yes. Other box. I always recommend drawing the figures. I know that we're kind of all self-conscious about drawing, but it doesn't have to look pretty. My lines aren't straight, but as long as it can help you visualize, I say draw it every single time. Write it down. All right, I'm gonna move along. So, I'm gonna write a problem on the board. I want you to find the area on your whiteboards, okay? So I got your marker and the board out. Find the area. You guys ready?
Yeah.
All right. love that Jeremy's drawing out his figure. Good. I see people checking their notes. Good. Corey's drawing his figure out. Nice. Alright, show me your board. And 5, 4, 3, 2, and 1. Show me your boards. Correct, correct. Incorrect, incorrect. Incorrect, 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 incorrect. Correct all the way in the back. Hold on, I said. Incorrect, incorrect. So, if you got 64, raise up your board. You got 64. Just 64. Why is that incorrect? Somebody tell me why. Kai, why is 64 incorrect? Thanks, Kai. Kai, why is that important?
Because we have to put like, we have to put the unit,
We'll help her out.
You have to put the film and you have to put the aerial.
You gotta put the units, right? Every time. So, maybe you did the math correctly. Area equals length times width, which is equal to 4 times 16 equal to 64, but you gotta include your units, right? We're in centimeters, so the answer's gonna be centimeters squared. Every time, y'all. What's gonna be wrong? Every time. Okay? You got it written down? Write it down. On the west side.
right now. Or can you write it like with the purple box?
All right, right here.
Yeah. Oh, yeah.
All right, find the area. Good. Oops, sorry. Lou was drawing out his figure. Good. Simon Phillips drawing a figure out. Jeremy drawing out his equation first. Good. All right, show me your board. 5, 4, 3, 2. Wrap it up. And 1. Show me your boards. So. Got 9 inches squared, 9 inches, 9 inches, 9 inches squared, 9 inches squared, 9 inches squared. So, for those of you that have 9 inches, is that correct or incorrect?
Incorrect. 9 inches squared.
That's about 9 inches squared, okay? You gotta show that little 2. Yeah. Show the little 2, y'all. Don't let that little 2. Don't let it mess you up, okay? Alright, let's do one more. Find the area. Find the area.
Meters.
figure out, very nice. Alright, show me your board. 5, 4, 3, 2, and 1. Alright, good. 4, read the square, read the square. Be careful, Philip. Don't forget, you're missing something. Read the square. No, Sana, I know that these, you do some of these in your head, but they're gonna get complicated, right? So we're gonna have it showing your work, okay? Alright. Nice, lady. Good job, Dylan. Good. Alright. Let's move forward. So. What? Okay, go ahead.
What do you know about?
So, now here, read the board nice and loud, please.
What do we know about squares and rectangles? Are they different? What makes them the same?
So,
You know.
in your groups, take a few minutes, a minute or two, and ask yourself, are rectangles different from are rectangles different from squares?
I would say.
Are they the same? What makes them different? What makes them the same?
What makes them the same is the same. They're both four sides.
It's in the family of it, but they're not the same because it has its own width and length and compared to the square.
Different. Good. I didn't reply to that. Good.
I'll write down what I'm saying.
Yeah, the rectangles got longer length. I mean, all length.
Okay, what about squares? What makes them different?
They got more work. They got more work.
What makes a square a square?
It's like more wide. We gotta write it on the left. No.
So a square has what?
Or what?
Or what? What about the size of makes it a square? Is it even or are they different? It's even, right? Draw a square on your board.
It's not true already.
Right? Draw a rectangle. What makes them different? Nothing. Even, right? Mine, the sides are more together, more the same size. So, square has 4 sides, so the side is 4 This side is 4, this side is 4. What's this side? What's this side? See how that goes in? Rectangle. This side could be 4. This side could be 4. This could be what? 2. 2. Yeah. So the sides are always the same in rectangle.
Oh, you wrote it down? Like,
Okay? So these are always even. All right, let's bring it back in 5, 4, 3, 2, and 1. What do we know about squares and rectangles to the
so what I said was that basically different Well, I'm calling it all about squares, like, they both got, 4 sides.
Good, so, square right here. Squares. Rectangles. Squares got 4 sides. Are they 4 even sides or are they different? Well,
No, they're even.
4 even sides, right?
And rectangles have 4, well, 2 even and 2. No, because so they have 2 lengths and 2 widths. So that means they have 2 that's even and 2 that's even.
Alright, so yeah, rectangles have 4 sides,
But not all of them are even.
only 2 equal sides, right? What else? See, right hand. Y'all were talking for a while, that's why I'm talking about. Move forward. You guys got it.
They said the same thing we had.
Can you hear me?
They said the same thing we had.
The exact same thing?
Mhm.
Nothing else?
Mhm.
Who got where else? Go ahead. Jeremy. Of course, wait.
Are we doing the same, right?
Same or different?
Okay, the same about the way both are closing out.
There's both quadrilateral rules. Okay, good. How do we know that?
Because they both are close out.
Both are quadrilaterals. Okay. Good. What else? Group 5.
We think that, it looks like they would probably be, different areas. Depending on which one that you're gonna choose.
Okay.
If you compare the two, if you did both of it, so if you did the area for rectangle and then for square, and you see,
No, that's where you're going. Keep going.
and you see how far they live apart, you probably.
Alright, so different areas, right? You put different areas. Same equation though. Alright. What do we know about squares? Give you a hint.
Equal, both,
They
90 degrees.
What's this little box meaning right here in the corner?
90 degree angle.
Hmm? So squares have what? 4 90-degree angles.
And rectangles have 30. Hold up. They have 130, right? Rectangle.
Say it again.
Rectangles, they have 100. They're like 130. No,
Just write it down. We'll come back to it. Okay?
And Mr. Walker.
Oh, just write it down. Let your thoughts, we'll come back to it. Okay. So, Jeremy had a buzzword, quadrilaterals, right? And somebody read what a quadrilateral is.
Remember they have 4 sides.
Think board. Can you read it nice and loud, please, somebody? Good enough. Nice and loud from the back, please.
We're gonna start from the top. A quadrilateral is a two-dimensional shape with 4 sides and 4 angles. Some quadrilaterals have special names such as trapezoid, parallelogram, rhombus, and square. You can use the properties of quadrilaterals to name them. Let's find out how.
All right, so please write this down in your notes, all right? The definition of quadrilateral is a two-dimensional shape, 4 sides and 4 angles. Hey, two-dimensional shape, four sides, a two-dimensional shape, four sides, four angles. Everybody done right? Another 30 seconds. Four sides, four angles. Let's go through that. Alright, so if you notice, some quadrilaterals are not always going to be squares and rectangles, alright? So we got this little like diamond shape here, alright? Or there's like SpongeBob kind of like shape, I don't know what it's called, but it has four sides. That looks like SpongeBob, right? But it has four sides. So we got one side, two sides, three sides, four sides, and then four angles. One here, two here, three here, four here, okay? So it makes it quite a lot. Same here. Sort of like arrow thing. Got one side here, two sides here, three here, and then four here. Okay? And then for our angles, we got one here, two, three, we got four on the outside here. All right? Alright, so classifying quadrilateral. So for one, we have a parallelogram. Write this down, please. Parallelogram. Everybody say parallelogram. Nice parallelogram.
Is there a word in that? Do we know? Raise your hand. What word is it? Gram is in there. Parallel. You know what parallel means? Not quite. Thank you for raising your hands.
A parallel is something with two equal, like two pairs of two lines that will never connect with each other. Or
Good.
Well, they can go on forever, right? And
Yeah.
they'll never ever touch each other.
Think of like a pair of train tracks, right? Train tracks never cross over, right? They just stay with a little gap in between them forever and ever and ever and ever. Okay? So you guys notice here, this shape here, just the parallel lines. You got a pair here. You got a pair here. Also got a pair here. And a pair here.
But you said they don't touch it.
They don't touch.
It's the way she's drawing it.
So like these pair never touch each other. And these pair never touch each other. Okay? And to label parallel lines, pull an arrow right here. Okay? got a second pair of parallel lines. Put 2 arrows. All right, our next shape is a rectangle, okay? Jeremy, rectangle is a parallelogram for right angles. So you're asking about 4. Rectangle also has 4 right angles. Okay? Well, we'll talk about that later. Let's talk about degrees just yet, sir. But I'm not ready for it. I can't feel it. I can't just talk to you. So I have a question for you guys. Is a rectangle a square?
No. Yes. Yes, it is. Is in the family of square. A rectangle is in the family of square, but it just has different width.
Alright. Raise your hand. Let the comment. Is a rectangle a square? Anybody else? Any other ideas? In the back, Mia. Look, you're thinking of the arm back there. Is a rectangle a square?
No,
Why not?
it only has 2 equal sides, and the squares have all equal sides.
I agree. Alright, let's go forward. Everybody else copy the definition, copy down.
Yes.
Rectangle is.
Yes.
No. Tyler, can you proof, okay? You can't wait right now. Go ahead.
Rectangles are in the family of squares, but like they have different width and length, but they're in the family. They're in the same family as squares.
That's a nice way to look at it. They're like the same thing. But they have everything, a lot of things in common, right?
Yeah,
They have
but
right angles, but squares have one side. Alright, so take another 10 seconds. And move forward. Alright, so rhombus is a parallelogram with 4 equal sides, alright? What's the difference?
They all sound.
the longest line.
Hands up, please. Hands up, there's too many conversations going on. What's the difference between a rhombus and a parallelogram?
God said it's different, a rhombus and a square because they look the same.
Well, let's see it. What do we know about? Look at the little angles right here, right? What do we know about squares? Yeah, 4 what? Yeah, 4 what?
Right, 90 degree angle. 90 right. Well,
4 90-degree angles, right?
yeah.
What kind of angles are these here?
90 degrees.
They're not 90 degrees, right? Are they bigger or smaller?
Yeah.
Yeah.
Say it nice and loud, man.
Acute.
Not
Acute.
What does acute mean?
I'm not sure what it means, but I think it means it's clearly not less than 90, but it's like a 30 degree angle, I think.
Acute angle means less than 90. Less than 90 degrees. Okay? Yes, ma'am, write it down. Get it done. Alright, our next one is a square. You know what a square is. It's got 4 equal sides, 2 pairs of parallel lines, and also 4 right angles. Okay? Write it down. Good. And finally, we have a trapezoid. Okay? Alright. Trapezoid has 1 pair of parallel lines. Alright. Got a line here, a line down here. Okay? 2 acute angles. Trapezoid. Oh, let's move this right here. Thank you for those that have notes written down. Your notebooks. Make sure they're available for the future. Come back to them and recall this information. Make sure those are the patients that are finished writing their orientation. Classmates to finish. Those that are not finished, take another 30 seconds. Alright, move forward. We're almost done, y'all. So, we're on a little riddle time, okay? Alright? So, can somebody nice and loud read these riddles for us? Philip.
I have 4 right angles and all my sides are the same.
Wait. Well, first of all, on your board, I'm going to draw it. Your whiteboard, draw it. Draw what the shape looks like. So write his name on your whiteboard. Yeah. Riddle me this.
Oh, God.
On the board?
Draw the shape, write his name. Draw the shape. Write his name. 4 right angles. On my side, same. What am I? Show me your board. 5, 4, 3, 2, and 1. Square. Hey, I like that board. I like that board right. Frank, why is it a square?
We got 4 right angles in there. And the sides, it's the same look.
Alright, so it's. What about if somebody's. Anybody write a rectangle?
Excuse me?
Why is it not a rectangle?
Reason.
Oh, the very answer. God.
Because all of it